Hello everyone. So in today's video we're going to do another variation of our dynamic routing series, and in this video we will be trying to use a single network ID and in all the VLANs. If we do a quick recap, in this topology we are using three different VLANs, 10, 20 and 30 on campus A, but the same VLANs exist on campus B. So it's a unified VLAN environment, but the network IDs are different. For example, in campus A we are using 10, 20 and 30 network IDs, and campus B we are using 40, 50 and 60 network IDs. So in this video what we are going to try is we are going to use a single network ID, and then we are going to subnet it according to our need. For this scenario we are going to suppose that we need at most 16 network IPs in a certain network ID. So the first network ID with respect to the subnetting would be 10.0 and the second would be 10.16, just like I'm doing the changes here. So the third would be 10.32 because we will just keep on adding the 16 and we will get the next value. So 10.32-2, this is the second device of 2. So let's do the same. Now this 40 would be changed to 10 dot, and this would be 16 and 32, and this would be 48, and this would be 10.48-2 machine, 10.64, and then 10.64-2, and the last one 10.80 first machine and 10.80 second machine. So these are the network IDs that we will be using. So if you see, we are using the same network ID and we have subnetted. The network ID here used is 192.168.10.0 /24. So that was subnetted into a /28 network, and in that way we have divided our bigger network into different smaller subnets that can act the same way as a bigger network. So right now we just have one network ID, but we made 6 different network IDs by subnetting them. So this is the change that will be done in the diagram. So let's now implement these changes. So obviously, since the IPs are changes and we are using dhcp to get our IPs, so we will have to configure these pools again. So that's the thing, and the same way we will have to make some changes. So for example, this is the current configuration for router A. So obviously we will have to make changes here. We will have to configure the IPs again, and then we will have to configure the network IDs for the pools. So we will have to pool these pools will also need to be generated again. So we will be doing these changes and then these changes in the network interfaces, and then we will also have to do some changes in the routing, because in our previous topology we were using 10, 20 and 30, so those routes are right now advertised, so we will have to change that. So same way NAT is also implemented, and NAT is also using this access list, so we will have to modify that also. So let's start these modifications. So first of all, let's configure the interfaces, this one, the sub interfaces that are connecting each VLAN. So it was using 10.1, so it can remain 10.1 for but for 20, this one, that is the 20.1, we will be using 10.17, and for that's dot 30, that will be connecting to the this VLAN 30. It was using 30.1, but right now because we have changed the IP addressing scheme, because we're using subnetted IPs, so the IP would be 192.168.10.33. so let's do the changes here first. So let's go to the global configuration mode, the interface FA0/0.10. so this is the sub interface connecting VLAN 10. so let's just update the IP address .10.1. Okay, but the subnet mask would be changed, since the default subnet mask is 255.255.255.0. So right now we're using subnetted IPs, so it's using /28 IP, /28 network bits. So the subnet mask would become not 0 but 255.255.240, because in that way we will get 16 IPs in each subnet. So let's do that. That's the first update. Let's go for the second, FA0/20. What did I do wrong? Sorry, yeah, 0/0.20, and let's add IP address 192.168. Now it won't be 20 dot something, it would be 10 dot, and the second subnet ID starts from 16, so we will go to the first usable IP, that would be 17. so the subnet mask will remain the same for all, because we're using the same subnet IDs. So this is the second. Let's change it to /30, and let's give 10.33. okay, so let's check the changes. Okay, so subnet mask has been updated and the IPs are also updated. Okay, these are net inside. Obviously we don't need to change these things, we just need to change the IP. So right now the next step is changing the IP pool. So since we used IP pool name with respect to the network ID, so let's altogether make new pools. So let's do that. So now IP dhcp pool 10, and the same goes for, sorry, this was not 10, this was 10.0, and the second was 20.0, and same way 30.0. so let's check if the pools are not there. So there you go, there are no pools right now, so let's make them. IP dhcp pool 10.0. so the first network ID is obviously always 10.0, so this pool will remain the same. So even if we didn't make any changes there, it would still work, but obviously we still need to update the subnet mask. So either we can just update the default network, or we can make all the dhcp pools again, like we are doing right now. So the first thing is to provide the network 192.168.10.0 and then the subnet mask. So in our previous configuration we gave the subnet mask 255.255.255.0, but here because we're using a /28 network, so we will always give 255.255.255.240 as subnet mask. Sorry for that. Okay, so there you go. now we have to provide the default router 192.168.10.1 would be the default router. Okay, and we have to provide the DNS server, and we are using 888 as the DNS server. So this is IP pool 1. So okay, now IP dhcp pool, now 10.16 would be the second pool. Network 192.168.10.17, sorry, 16, because right now we are providing the network ID, not IP. So 240, and the default network here we will provide 17, 10.17, and the DNS 8.8.8. So let's go for the last pool, 10.32, and the network would be 192.168.10.32, and the subnet mask, and then default network would be 192.168.10.33, and the DNS would be 8.8.8. So after this configuration we should have the pools. So yes, if we did a show run, this is 10.0, this is 10.16, and this is 10.32. so now let's go see and if we have updated IPs here. So let's go to static for both. Okay, so let's try, and okay, so there you go, 10.2 and with the updated subnet mask. Okay, so let's go for the second one, and this is 10.3. good. So here we have the previous IPs. So if we, so there you go, 17 was the default gateway, so we have been given 10.18 as the first available IP. So let's go and do that for the second machine, static, and then again dhcp. So there you go. Let's do the same for the third VLAN. So there you go, 33 was the first and 34 was the second available IP. Okay, and 35. So let's try the ping, if we can ping the 8.8. okay, so right now we can ping because the 10 ID is in the allowed networks list, but we will have to change, because if we try to ping from the second one, let's see, 10.16, it can also work because the 10 network ID is already there. Okay, so there you go, we can ping, but we will do some slight adjustments because right now there are some network IDs that are not needed anymore. So let's do that. We just need the first line, this one. Okay, so let's do something. Let's copy this and let's paste it, and let's do a no to undo this, and let's again do that for the 30 network ID. Okay, so do show run, and we only have, okay, so it deleted the, yeah, obviously it would delete. So let's do this and permit only 10. Okay, do a show run again, and there you go. So right now what we have done is we have provided the whole 10.0 network, because if we take a look, we are using a single network ID that was subnetted. So if we want to permit all our subnetted networks to communicate with the 8.8.8 router, either we can do is we can add individual subnets, or we can just add the whole network ID. That would be quicker. So let's do this later and do the same modification that we did here on the other side, and then we will come at the last for EIGRP. So let's go towards the second router. First let's do some saving. So the configuration is saved. Let's go to the second router, en and show run. So you can see we have pools, so we need to make new pools. We also have to give new IPs, and obviously we will do the changes here, but then again this will have to go, and we will add a new entry just for 10.0 network. So let's do that. Let's go to the global configuration mode, and first go to the sub interfaces. So for example, this is the 40 interface. You can see this was the interface that we were using. No, actually it was 10, 20 and 30, the same. It was the network ID was same. So let's do that. Let's go for 0/10. Okay, and update the IP address 192.168 dot, and that will be 10.48. So the 48 was the network ID, so the available first valid IP would be 49, and the same subnet mask 240. Okay, let's go for the second 0/20 IP address 192.168.10. This was 64, so the IP would be 65. 240. Okay, so let's go for 30, and the IP would be 81, because 80 is the network ID. So there you go. Do an exit to show run and check the updated interface. So yeah, 10.49 for the first one, and 65 for the second, and 81 for the third. Okay, so let's make these pools again. So let's go for that. No IP dhcp pool 40.0. that was the first one. The second was 50.0, and the third was 60.0. So let's check. So there you go, there are no pools right now. So let's make new pools. IP dhcp pool 10.48, because it will give me IPs from the 10.48 subnet ID. So let's choose the network 192.168.10.48, and the subnet mask 240. So next give the default network 192.168 and 10.49. okay, and the DNS will be same 8.8.8.8. okay, so let's go for the second DHCP pool. DHCP pool 10 dot, that would be 64, and the network would be 192.168.10.64, and the subnet mask 240, and the default router would be, or the default gateway would be 10.65, and the DNS would be 8.8.8. and let's go for the last pool, that is 10.48. 84. Okay, so let's give the network 192.168.10.80 would be the network, and the subnet mask 240, and the default gateway, oh sorry, that's 192.168.10.81, and the DNS would be 8.8.8.8. So that should conclude our dhcp pool. So 48 network ID and 48 and 49, and then again 64, 65, then again 80, 80 and 81. So that should conclude our dhcp pool. So let's go and check the IP. So let's go and switch from static to dynamic, and we should get, yeah, there you go, we got a 10.50 network IP that is part of the 10.48 network ID. So let's again switch from static to DHCP to get new address. There you go, 50. Here we should get 66 as the first IP. So let's see. Now there you go, we have 10.66, and then again we will go and do it on the second client, 10.67, and then the third VLAN, this should be 82, yeah, there you go, and this should be 83 when we switch to DHCP again. There you go. So let's try the ping, and it won't work because we don't have the 10 network ID in this scenario, because on campus A we had the 10.0 network ID, so we just removed the other IDs and that IP, so we were able to communicate. But if we remember, if you go into our routing configuration, and then we can see the access list here contains only network IDs 40, 50 and 60 that are not even present in our current configuration. So we have to delete this access list and then add the respective IP. So let's access list 10, and let's do that to save some time, and then paste it and permit only the 10 network ID. So there you go, that's the only change required for the ACL, and hopefully we will be able to do our ping now. So let's try from the first VLAN. There you go, we can ping the 8.8 server. Let's try from the second VLAN of second site. We can ping it router, and then again let's try doing that from the third device again, and right now we can ping it. So what we can do right now is we can ping each other within the VLANs, and we can also ping the internet router. But what was the ultimate goal was that we should be able to communicate these between these sites. So for example, the 10.0 network ID can be able to ping the 10. For example 64 network ID. For example, let's try it, and let's try to ping 192.168.10. and 64 is the network ID, 65 is the default gateway, and 66 was the first available IP, for example. And let's try it. So it's giving a destination host encryption because there is no routing right now, because the routing is there actually, but it's wrong, because this is the routing, but it's wrong. So let's update this routing configuration. So what we need to have is we need to have the specific network IDs present, because right now it only contains 10.0, but we have 10.0, 10.16 and 10.32. How can we know that? As you know, we can just check our routing table. So there you go, this is the present, that is 10.0/24. So we will first remove these okay, and then make some new routes. So let's do that. Or we can advertise the whole routing table again. So let's since we are removing all the previous configuration and doing from scratch, let's do that. So let's know router EIGRP 100. Okay, so let's see, do show run, and hopefully the routing configuration should be done. Yeah, there you go. We don't have any routing configuration right now. So if we, for example, check the routing table, right now we only have the static routes and the direct routes. Okay, so this is the 10.0 and this is the 10.16 and this is 10.32. So as you know the routing principle, we need to have these IDs present in the second router. For example, let's go to the second router and no router EIGRP 100, for example. So let's verify no routing configuration. So there you go. Now there is no routing configuration and there are no routes here. So this only contains the directly connected, as is 48, 64 and 80 network IDs. So these should go in the other, and the A's network ID should be present here, and we will be adding these routes using the dynamic routing protocol method and by using the EIGRP protocol. So let's configure the protocol. For example, router EIGRP 100, and let's do the no auto summary command first. So these routes are represented by their original subnetted network IDs, not the summarized network ID. Okay, so let's do that. 192 network 192.168. I already showed you how we can advertise using EIGRP. Different methods are used to advertise. So right now I am only going to use the basic method, the com, that is just like we do in RIP. So the first network ID is 10.48. There you go. This is the first network ID. The second is 10.64. The third is 10.80, and the last that we need to advertise is where is the network? There you go. This is the network ID that we also need to advertise, because this is connecting over these two networks. Okay, so let's do the last one, network 1.1.1.0. okay, 1.1.1.0. okay, so let's exit, command to show run. So there you go. So right now if even if we are using subnetting network IDs, it will give us the summarized route if we go to the running configuration, but we will see that that due to this no auto summary command, the routing table will not contain a summarized route, but it will contain the original network IDs, those in the subnetted network IDs. So let's complete the routing process, and then we will be able to see the changes. So router EIGRP 100, no auto summary, and then advertise network 192.168.10.0 and 10.16 and 10.32, and the last network ID would be this one, 1.1.1.0. And as soon as we did that, you can see the neighbor message came up. So right now the exchange has happened. Sorry for that. So let's check the configuration. Same way we will be seeing a summarized route, but now if we let's go to the enabled mode, show IP route command, we will see, because of the no auto summary command, we are seeing the original subnetted IPs, not a summarized address here. Okay, and let's write the configuration. Let's verify on route 2B. So the message is there. Let's pull up the routing table. So there you go, 0, 16 and 32 has been added to the campus B router through EIGRP. You can confirm by the symbol used in the routing table. So let's write the configuration. So let's now try and ping the PC that we try to ping again. Yeah, there you go. So now as you can see, we can ping the machines from our site A to our site B. So that's how we can configure dynamic routing using EIGRP and with the help of subnetting network IDs. So until next time, take care.